In this video, we're gonna go over some of the most advanced and most useful features of my agency swarm framework. As I have noticed, most of you guys are not even utilizing 70% of its potential. So here's what we're gonna go over today. First, I'll show you how to use asynchronous mode properly, both for the agents and, as introduced in the latest release, for the tools. This can speed up your agents and make them up to 4 times faster. Then we'll proceed with parallel tool calling, a new feature both in OpenAI Assistance API and in my framework. After that, we'll discuss advanced agent parameter and techniques like few-shot learning, response validators, fine-tuned models, and more. Then we'll discuss how to properly convert OpenAPI schemas into tools, which is hands down the most underrated feature in my framework. And lastly, I'll show you how to run open source models with Astra Assistance API in just 5 minutes. Yes, you've heard that right. Now, with Astra Assistance API, it only takes you 3 lines of code to set up my framework with any open source models. So, if you're serious about AI agent development, let's dive in. Okay, before we get started, I just wanted to let you know that we're still looking for technical project managers and AI agent developers to join our team. So if you think you have all the necessary qualifications, then you can apply using the links below. Now let's jump into the notebook. You will find this Colab Notebook in the description. Please make sure to open and follow the tutorial along with me. This will allow you to learn all of these concepts much faster. The first step, like always, is to install the packages. I'm going to be installing it from a special branch that I'm currently using to develop the new features, but by the time you watch this video, you should have already the new version released. Then, like always, just drop your OpenAI key into the cell below. Okay, now we're ready to get going. So here's the first exercise, which is the asynchronous mode. Right now, we have 2 options. The first mode is called threading. So if you set asynchronous mode to threading, it means that each agent will run in a separate thread. Let's see an example. Let's define a simple my custom tool. Then let's define 2 agents, just as an example, a CEO and an essay writer. And then let's set up the agency itself. Awesome. The next step is to run the demo command so we can use this agency directly in this Colab notebook. As you can see, I set the async mode to threading. So whenever the CEO sends a message to the essay writer, it no longer has to wait for the response. The essay writer will now be running in a separate thread, and the CEO can check the response later. This is extremely useful when you have agents that output extremely long text. So for example here, the essay writer is instructed to write comprehensive and well-researched essays, meaning that the output will likely contain a large amount of tokens. So let's try this out. I'm just gonna say to the CEO, please write a comprehensive essay about AI. As you can see, it then sends the message to the essay writer, but now, instead of the CEO having to wait for the response, it tells me that the task of writing a comprehensive essay about AI has started. This means that now you can tell the CEO to execute some other tasks. For example, now I can tell the CEO to use the custom tool. As you can see, while the essay writer is still writing the essay, the CEO can now use this tool and then tell us what the output is. So now, in order for us to get the final essay, all we have to do is just to remind the CEO to check the response from the essay writer. So then, as you can see, the CEO relays this full and comprehensive essay written by the essay writer while the CEO was responsible for executing some other task. Amazing, right? Okay, let's stop the cell, and now let me show you a new method called tools threading, because oftentimes you might not want your agents to run in separate threads. Instead, when you have some extremely complex tasks that are heavily dependent on the tools rather than on agent outputs, you might want the tools to run in separate threads instead. So this is why I added this new tools threading method in the latest release. Let's try another example. I'm gonna set up another custom tool and another agent called CEO again with this tool. So the agency this time is just gonna contain one agent, which is the CEO. And first we're gonna run this agency without any async mode, just so we can time the execution and then just so we can compare it with the tools threading mode. So my message to the agent will be to use 2 another custom tools at the same time. So it means that now this agent will try to execute the another custom tool twice. And as you can see inside this tool, we have time sleep set to 25 seconds, which means that this tool execution will take at least 25 seconds to complete. Yes, so as you can see, we now have this final execution time, which, as I said, 53 seconds, because the agent was required to execute this tool twice. Now let's try the same tool, but with the new tools threading method. Again, we're using the same prompt, use two another custom tools at the same time, which means that the agent will execute this tool twice, but now those tools will run in separate threads. Yes, so now as you can see, the execution time is only 28 seconds, which is already twice the speed. Now imagine if you have 4 of these tools. Obviously, this can be crucial in production because increasing the latency even by 10% is extremely important. When here we were able to increase it 2 times simply by setting async mode to tools threading. However, keep in mind that the threading modes do have some limitations for CPU bound tasks. So whenever those tools require heavy CPU usage, like if you're doing some processing, you can run into some issues with the performance. However, when you have input-output bound tasks, like if you are waiting for an API response, then threading mode can be extremely useful. In the future, I will of course also add the multiprocessing mode for even more complex tools, but this might take some time. Okay, the next feature that was recently introduced in OpenAPI is control for parallel tool calls. So yeah, as you can see here, OpenAI again silently introduced this new parameter called parallel tool calls. So if you set parallel tool calls to false, essentially your agent will be forced to call each tool sequentially. While if you set it to true, which is the default, the agent will be able to call multiple tools and execute them at once. So let's try an example with the same agent with another custom tool and parallel tool calls false. I'll use again the tools threading mode, which, as you might recall, took us around 28 seconds to complete. Let's run the same prompt to use 2 another custom tools at the same time and time it again. Yes, so as you can see now, the wall time is 55 seconds, even though we're using the tools threading mode. So let's look at this thread on OpenAI. As you can see, the agent indeed called 2 tools, but now, because the parallel tool calls mode was set to false, the agent called them sequentially rather than 2 at the same time, even though the prompt did say that it needs to call them together. Awesome. However, there are some instances when you might want only a certain tool to run sequentially, when all other tools must be executed together. So for this, I added another special one call at a time parameter into the base tool class. So let's try this with a pre-made agent example. I'm gonna import agent David with the agency swarm import agent command. Now, as you can see, our agent David will appear on the left. It has a few tools that I've developed for software development, like for example, file writer tool, I believe uses one call at a time, because the agent first needs to know what was written to one file before it can proceed to writing another file. So as you can see here, I'm setting one call at a time to true, and this means that the agent will be forced to wait for the first execution to finish until it can proceed to using this tool again, while, as I said, all other tools can still run in parallel. Okay, so let's try this with a simpler example. I'm gonna create 2 tools for a CSV sheet agent. The first tool is gonna be called create CSV sheet tool, and another tool will be called fill row in CSV tool. So basically, the first tool, as you can see, creates the CSV file and then saves the CSV file path to shared state. Again, guys, please don't forget about shared state. Shared state can be extremely useful to check, for example, certain order of operations in your agency, or save certain important information to prevent hallucinations and translate it between those tools. So as you can see here, basically the fill row in CSV tool doesn't ask for the file name, and instead it checks the file from this shared state. And if this file does not exist, as you can see, it returns a value error. So then the agent is gonna see this error and it will be forced to create the CSV file first. Alright, let's initialize this agent and try an example prompt. So I'm gonna tell it to add any row to the CSV file. Let's check the thread on OpenAI. Yeah, and as you can see, it first tries to call fill in CSV tool, but it runs into a validation error because the CSV file does not exist. So then it is forced to create the file first, and only then it can fill out this CSV sheet. Then it just tells me the response that it added a few rows, which looks something like this. Obviously, guys, this is a very simple example, but it's extremely useful in production. Right now, the biggest problem that prevents mass adoption of AI agents is hallucinations. And when you can check state between certain tool executions, it allows you to make your system a lot more reliable. Okay, so now I'm gonna run another prompt and tell this agent to fill in 2 more rows at the same time. Okay, let's check the thread. And by the way, make sure to select the correct project, because if you try to view the thread for an API key and you're currently using a different project, you're not going to be able to see those messages. Okay, so here's my prompt. As you can see, the first function execution was successful, but the second one returned an error because the fill row in CSV tool is already called. So then the agent was forced to add in the rows one by one, just like this. Awesome, now let's get to the next section, which is advanced agent parameters and techniques. So first of all, we have few-shot learning. Even when creating agents, please don't forget that large language models are a few-shot learners, so oftentimes it's much easier to provide a few good examples rather than work for hours on a prompt. Here, for example, I'm going to be doing a basic customer support agent, and I want it to always respond with certain emojis. So instead of instructing it to do so, I'm simply going to include a few examples where this agent responds with emojis. As you can see, we got a few very basic questions that a customer support agent might encounter, like for example, the features of certain products or statuses of orders. And by the way, you can also insert additional information in few-shot examples, so the agent will be able to actually retain this information and use it later as well. But here we're going to use it for a basic style transfer. So as you can see, my agent has no instructions whatsoever, and I'm basically just initializing this one agent in an agency and then asking another very basic customer support question. All you have to do to add few-shot examples to the agent is simply use the examples parameter inside the agent class. Keep in mind that all the parameters in my framework follow the exact same format as on OpenAI API. Awesome, as you can see, the agent then provides me with some instructions, and at the end it includes emojis because it saw all of those previous examples where we also include similar emojis, even though the instructions for this agent are empty. Okay, next we have response validators. So response validators is definitely one of the most advanced features in my framework because it allows you not just to validate the inputs and outputs of the tools, but also the messages returned by your agents. So obviously, there is always a chance that the agent will hallucinate and won't return the required emojis, which is a significant violation of our customer support service policy, which is why we can add this response validator and explicitly check whether any of those emojis are in the message. And then, if not, we can return a value error saying that the response does not contain required emojis. The agent will then see this error and correct itself accordingly. Let's see how it works. Awesome, as you can see, it then returns us another message with even more emojis than before. And if we look at this thread, we're gonna see that if the first time the agent hasn't returned any emojis, like here, it's gonna see another message by the user, even though I didn't send any message, with our error. So the error is response does not contain any required emojis, which is why it then proceeds to printing the response with a lot more emojis as requested. Awesome, next we have fine-tuned models. So I'm not gonna go and test these parameters below because you can do it yourself really fast. Basically, if you have any fine-tuned models, you can now use them with OpenAI Assistance API. So simply replace the model parameter with your fine-tuned model name, and then instead of providing few-shot examples, the model will always generate responses in your style. Then we have file search config, which is again a new parameter that OpenAI has silently released, and essentially it allows you to control the configuration for the file search tool. Right now, only the max number results parameter is available inside this configuration, and it allows you to set the maximum number of results that the file search tool should output. So if you set 20, it means it's going to return 20 chunks, while if you set 50, it's going to return 50 chunks. It works in my framework in the exact same way. Under the agent class, you will find this parameter, and you can set this number between 1 and 50. And lastly, we have some more advanced truncation parameters that allow you to define, for example, how long the output from the agent must be, and also how much context the agent is going to use to generate a response. So if we set max prompt tokens parameter to 2048, the agent will only respond up to 2048 tokens, and then the response will be cut off. If you set max completion tokens to anything like 16,000, it means that only up to 16,000 of tokens will be used in the conversation history to generate the next response. Additionally, we also have truncation strategy, which defines how the messages are truncated. By the default, it's set to auto, which is a special truncation strategy used by OpenAI, where they keep the beginning of the conversation and the end, but they remove the middle messages. And lastly, we also have a response format parameter, which can be set to JSON object. With this parameter on, the agent will always respond in JSON. However, keep in mind that to use it, you also have to include in instructions that the agent must always respond in JSON. Okay, the next feature that I'm gonna show you is how to convert OpenAPI schemas into tools. Basically, you can do this in two ways. You can either specify a schemas folder when creating your agent and then drop any schemas into this folder. All of those schemas will then automatically be converted into tools. If your schema requires authentication, you can set the API headers parameters or other API parameters accordingly. Then all you have to do is just initialize the agent and run it. It will then automatically have access to your API. Additionally, you can use tool factory class for this. You can use from OpenAPI schema method and even fetch it with requests if your schema is hosted somewhere online, and likewise provide headers and parameters accordingly. So here you might be wondering what's so cool about this and why is it like such a groundbreaking feature compared to all other frameworks. And the answer is because Tool Factory actually converts all of those schemas into base tools with instructor. So this means that these tools are all type checked based on your OpenAPI schema definition. So it doesn't matter how complex your schema is, how many different parameters you have, all of them will be automatically converted into instructor-based tools. This means that your agent will check all of these parameters before calling the API. So instead of the agent first calling the API like it happens on custom GPTs or on all other frameworks and then getting an error back and then trying to correct itself, it will check all the parameters first. So if it provides any incorrect parameter, it will receive an error before it calls the API, which allows you to significantly reduce production errors. And lastly, we have some advanced parameters for backend integrations inside the getCompletion method. So getCompletion method is how you get, the response from the agency, and here you can specify a few things. First, you can specify the recipient agent. So if the primary point of communication in your agency is a CEO, you can still specify it to some other agent like David, and then it will receive the message. Then we also have additional instructions. So additional instructions are instructions that will be appended to your agent only during the execution of this run. This is extremely useful for any session or user-specific information. Like for example, if you want your agent to know something about the current user who's using the system, additional instructions is the place where this information should be. And lastly, we also have tool choice. Tool choice allows you to force your agents to call a specific function. So for example, here, as you can see, I'm forcing the agent David to call the file writer tool. And finally, let me show you how to run my framework in just 5 minutes with any open source models using Astra Assistance API. So Astra Assistance API was developed by DataStax, and essentially it's a drag and drop replacement for OpenAI Assistance API. Make sure to give them a star on GitHub. So let's install Astra Assistance API with pip install, and then what you need to do next is simply grab the AstraDB application tokens. So follow this link, log in with your account, and then you'll be taken to the AstraDB dashboard. I'm not even affiliated with them, but the pricing is extremely cheap and they do still provide a huge free quota, which is more than enough for you to get started. Go to tokens page and then create a new token for organization administrator. Click generate a token and then copy the third value, which is the token value that starts with Astra CS. Take this token, run the next cell and place it below. Next, insert all of the API keys that you want to use for third-party model providers. So here I'm gonna use Perplexity, Anthropic, Together and Grok. You can add more providers as needed. Next, all you have to do to set this up with my framework is simply patch the OpenAI client with a special patch method from Astra Assistants and then replace it with the set OpenAI client method. Now, as you can see, the OpenAI client will now communicate to Astra Assistance API. Then, like always, all you have to do is just create your agents, but replace the model names with whatever models you want to use. So for example, here I'm going to create a Grok agent that uses Llama 3, and additionally I'm going to create a Claude 3 agent that uses Anthropic. All of the other parameters like files, folder are already supported by Astra Assistance API, so you can add it like this, create a files folder on the left, drop your files, and then the agent will be able to provide responses based on the file context. Alright, let's run the demo gradio method and see how it works. Cool, so now let's ask the Grok agent what LLM is here. Awesome, so then it tells us that it was indeed developed by Meta AI. Additionally, you can also run Astra Assistance API with Ollama fully locally. For this, make sure to check out Astra Open Source Swarm directory on GitHub, where someone from DataStack's team will kindly added this new example for how to run local models with Ollama. So the first step is to install all of the requirements from the Astra Open Source Swarm directory. Simply create a virtual environment and then run pip install-r requirements.txt. Then copy the env.backup file and rename it into simply .env. Here you can insert all of the foundational model provider API keys that you want to use. Also, don't forget to add your AstraDB application token on top. Then open the Docker Compose file. The Docker Compose file will pull a couple images here. The first one will be for Ollama and the second one for DataStack's Astra Assistance API to run locally. However, if you have already installed Ollama previously, you can simply comment the Ollama image and then run docker compose appd. Awesome, as you can see, both containers have started. So the last step is to simply run python agency ollama.py. Awesome, as you can see, we can now open the same link again, and let's ask the CO agent to ask the Llama agent what LLM is it. So then, as you can see, the Llama agent indeed tells our Claude CO that it's using Llama model. Amazing. So yeah, that's it basically for the advanced features of my framework. A lot more advanced features like observability and more async modes are coming shortly, so make sure to subscribe.